Hello, I am Dr. B M Patil from MIT World Peace University. I welcome you all for first session on cryptography, a way of information security tech talk. In this session, I am mainly focused on cryptography basics and various algorithms related to cryptography. So let's start with the quote from Benjamin Franklin. Once he said, "Three people can keep a secret if two of them are dead." It means that due to the human tendency, it is very difficult to keep this data secure because human tendency is like this. They want to share this secret information with their colleagues or friends or other people. Similarly, we have got a lot of information or data on our storage devices, or we share a lot of information on our um, public channels. This information is necessary to be stored as well as secured from the unintended users or attackers. Similarly, there is a trust in all the parties. This is another reason for to, or this is another difficulty to make security of this data as it is. In the trust, we have this sender and the receiver, as well as we have this a key distributor. There is the third party which is also involved. So unless and until all these three parties they have the trust in each other, this communication or this data transmission is not fruitful. Subsequently, in today's scenario, internet it is become our lifeline. In the broader sense, we can say that almost all the jobs today we are doing online it is. So we are sharing our lot of information on online or in a public channel. This information is not so secure, or it can be vulnerable for the attacks, and the security of this information is must. And subsequently, that's why we are saying it. Information security or cryptography is one way to secure the information, and that's what the topic for the day. So let's understand what the cryptography is. Historically, we can say the cryptography is not today's word. It was started long time back, around 4,000 years back, the people started thinking about the cryptography. So cryptography word came from the Greek dictionary. There are two words which are there called as a cryptos. It means the hidden, and graphene means to write. So in short, if we can say that the cryptography is nothing but the art of transforming this information from normal information to unreadable information, that we can say as a cryptography. People are using the cryptography not in today's life, but from in history also it shows that the cryptography has been used for security in keeping the important communications, such as those of spies, military leaders, and diplomats. In recent decades, we found that cryptography has expanded its use in all sorts of lives, mechanisms for information security or keeping messages secret, or schemes like digital signatures or digital certificates. Even in today's life, for every activity, we need to go for doing the authentications. We have to use login and passwords. All that is related to this cryptographic information. So I'd like to take you to this roadmap of the cryptography. As I mentioned, cryptography was started long time back, that is 4,000 years before. But officially, people started mapping it on a roadmap from 1920s. So it started with the classical cryptographic algorithms, which are mostly based on transposition or substitution ciphers. They are prone to these attacks. They are easily broken based on statistical analysis also. Subsequently, during this World War One and World War Two, there are mechanical devices which are used during these wars. These machines had played a very important role in the World War One and Two. There is a machine called an Enigma cipher, which is an electromechanical machine which is encrypting the information which is transmitted. During the World War II, people used to share this information among their military officers through these cryptographic messages. These are few sample pictures shows these machines which these military people has used during the World War II. The Sigaba is the word from the United States, Typex from the Britain, Lawrence cipher from the Germany, and so on. Subsequently, this invention of DES or development of DES has changed the information security scenario. This DES is the first standard algorithm which came for securing the information on public internet, as well as this invention of this RSA and use of this RSA in digital signatures has played very important role. So this RSA uses for doing this public key systems, and in today's life they are most widely used. Now, futuristically, considering this increase in computational power of these devices, so these cryptographic algorithms are prone to attacks, and we look forward for this cryptographic algorithm based on quantum cryptography. So cryptography has some similar words called as the cryptoanalysis and the cryptology. So cryptoanalysis is what in layman's language we can call it as a breaking the code, or it is opposite to this cryptography, where we try to convert the information into the unreadable format, whereas on a cryptoanalysis they are trying to break this creation of this unreaded format, or we can call it is also called as a code breaking. Cryptography and cryptoanalysis, if we combine together, we call them as a cryptology. This cryptography, we generally say it is an interdisciplinary subject because it involved linguistics, because frequency analysis we calculate it. It involved this mathematics because it uses the number theory or information theory, and engineering also. This plays important role in development of this cryptographic algorithms. There are similar other tools or fields we call it is, but they are not as a cryptography. We call the steganography is a similar one, but the steganography is a practice of hiding a message or a file within another media, for example, image or file or audio. Similarly, traffic analysis is done for identifying the patterns of communication in order to learn the secret information which is flowing through the channel. Now here we can look for this network security model where there are two main important component or participants. One is the sender and the receiver, but there are two extra parties which are playing important role in this. The one called as a trusted third party who is authenticating these all transactions, or authenticating this, identifying these users, or they are acting as a third party trusting members. Whereas on the other side, dangerous attackers are playing havoc on a public networks called as internet, and creating a lot of attacks and breaking these different cryptographic algorithms and making huge loss to this information technology. Here it is the diagram which shows that in a typical client-server communication or in a web purchases, we need to share our credit card or debit card details. These credit cards or debit card details are vulnerable to this public channel. Attackers can attack and then it increases the vulnerability. These attacks can be avoided by using this cryptographic algorithm, and it underlines the need of this cryptographic algorithm for securing this information which is flowing on a public network. Now, there are four main important features of a security. They are called as authentication, integrity, confidentiality, and non-repudiation. Authentication means identifying the trust of the sender, whether the same sender which we expect to send the information is the original or the same entity or not, can be identified using the different algorithms which are there, called the DES or RSA are there, as well as the a trusted member send the data to this um, to the receiver, but the integrity, is it hampered or the message has been changed, can be identified using the integrity checks, and we can use for that the SHA and MD5 algorithms. And confidentiality is the another major important issue. People call it confidentiality or privacy also. The message which has been sent from the sender and received to the receiver is not being seen by somebody else or not, can be checked, or this need to be ensured so that the security of that data is there. And then finally, one is called as a non-repudiation. In non-repudiation, the sender has sent the information and afterwards is denying for that. That is to be avoided, or that can be avoided using the third party trusted members, and that is called as a non-repudiation. So here it in diagram we are shown an authentication where there are sender A and receiver B is there. The sender B or receiver B need to identify that whether sender A is there or not, who is the original one, or in between the third party who came in, the sender C, and then pretending that I am a sender A. So this way we need to authenticate it using the login and password. This is possible. As well as the sender A has sent the information to the sender B, there is a ideal channel, but the data has not gone through this ideal channel, whereas it has been modified your channel by third party involving intruder, called as the attacker or intruder, who has taken the data from the user A, sender A, and then modified it and pass on to this receiver B, and then make the changes in the content. So integrity is hampered. As well as the when sender A will send the information to the sender B, there should be surety that this message is confidential. Nobody else has seen that, and how can it is made secure? That is possible using the cryptographic algorithm. And finally, we say that non-repudiation. Non-repudiation is that a sender A is there who has sent the information, and so afterwards is refusing it. So it can be avoided using the non-reputation kind of feature of this cryptographic algorithms. Now, let's go ahead with this. How we can achieve this security? We can achieve this security using the cryptographic algorithm. As we already mentioned, that cryptography is nothing but the art of transforming messages, okay, to the unreadable format. If you go for this cryptographic basics, we'll find there are two main entities. That's called the plain text and the ciphertext. Plain text is the all understandable messages or original message, and then ciphertext is all non-understandable messages or those messages which has been modified or transformed from the normal form to unreadable. Now there are different mechanisms, primary mechanisms or initial mechanisms, we call them as well as a substitution techniques and the transposition techniques. These are important techniques which are there, which came in initial period of time of the cryptography. The substitution technique is the very simplest one, where we replace one or more characters with the characters. For example, replace each E with D, B with E, etc. in a original message or a plain text which you want to transfer. There is another type of the cryptographic mechanism called as a transposition technique, where we are changing the position or transforming the position. That is also called as a rearranging the text. Replace first character with the fourth, second with the fifth, etc. Now, current algorithms, cryptographic algorithms, they are generally based on both the techniques, substitution and transposition, and they are called as a product ciphers. Now, we take the one simple example of this substitution cipher called as a Caesar cipher. Julius Caesar, a general of military, who used to share the information amongst his generals using this simple substitution cipher known as the Caesar cipher. When it replaces each letter of message by a letter of fixed distance away, generally they prefer it take 3. In the example, it has been given that I is replaced with L, C is replaced with F, A is replaced with the D, means there is a gap of 3, and the mapping is shown below with A, B, C, D, E, F, G, H. Subsequently, A has been mapped with the D, B has been mapped with E, C has been mapped with F, and etc. Now this is the simplest, the same thing which has been shown it. We got the input as a plain text, and we have got the key as a key equal to 3, where we have converted plain text to this cipher text with the Caesar cipher. While operating this, there are two entities called as encryption and decryption. They are playing a very important role in the cryptographic algorithms. So encryption is nothing but the conversion of plain text into the cipher text, whereas decryption is nothing but the conversion of cipher text into the plain text. While doing this encryption and decryption, there are two aspects called as algorithms and the key. They are playing very important role. Now, this diagram shows pictorially how the encryption works. Where we have got the input as a plain text, it is encrypted with the process, and then there is a ciphertext. Whereas on the reverse way, we have this input in the ciphertext. We have got in the outputs. In the decryption, we got the input as a ciphertext. We decrypt and we get the plain text. This is a sample example, this is the process, and this is a sample example which we got. Now, as we mentioned that algorithms are playing an important role in terms of two things. When we are designing the algorithms, it is expected to have that they have been computationally very difficult to break them, as well as or they should keep their security of this information till the usefulness of that information is finished. So subsequently, this encryption or decryption algorithm specifies the operations to be performed. This is a stepwise, we call it is, or we call it a function F. There are examples. We can create a DES idea, and then AES is there, where we assume this algorithm is known to everybody. Then on the key side, we say that we must be kept key is a secret, because key is the what important parameter, which all the time it should be kept secret. The key size is also playing important role in the making the secure information, where we say that there should be larger length of the keys should be there. Now the same thing is depicted using the key range. If you have the 2-bit key, we have the 4 possible combinations of the keys are. Whereas the 3-bit key we have the 8 combinations of these keys are. Subsequently, 2 raised to power n, if you have the n-bit binary numbers are there, then we can have this much. So in RSA, we use generally 1024 bits, since 1024 is 2 raised to power 1024 combinations of keys are generated across. Now, these algorithms are being attacked for main 2 purposes, either to recover the message or recover the secret key. Record the message is the one-time activity, whereas if we record the secret key, the same message can be unencrypted or encrypted using the secret key, the previous messages which we received or the future messages which we were expected to get received. So thus we can say that the number of keys possible must be large so that it can be more secure. Now here is the one generic attack which happens on all the algorithms. That's called as a brute force attack. It is a generic attack where attacker all the time tries for a possible key combinations on a ciphertext to get the legitimate or intelligible translation into the plain text. In this diagram, if you have seen that key 0, key 1, they tried one, but they didn't get any output as a fruitful output, which is meaningful output, we can say. Whereas the try with the key 9, the huge one, so where they could be able to decrypt it, and the ciphertext has been converted to the plain text, where we have called the meaningful plain text called as a payload. So generally in a brute force, it is more or less around 50% of the time they have to try for these keys and to get the output subsequently. Now there are two types of ciphers based on the input text we use to give it to the ciphers. They call it stream ciphers or the block ciphers. Their iterations at different places, they are playing very important role. The stream ciphers are playing very important role in case of this ATM pin entering, where every alphabet or every digit is going to be encrypted separately, so that it is a stream cipher. A single bit or a byte is encrypted at a time and subsequent cipher is generated. Where on the other side, where you have a huge amount of data you need to transmit it, that huge data you need to encrypt it, in such cases the block ciphers are preferably used, and a block of plain text is encrypted at a time and we generate a block of output using that called as a ciphertext of the equal. Here we have for next, we call it is a based on the key types also. We have the different cipher types called as symmetric key encryption or symmetric key algorithms, or we have this asymmetric key encryption or called as asymmetric key cryptography. Where in a symmetric key cryptography, same key is used for encryption and decryption, whereas in asymmetric key cryptography, one key is used for the encryption and another key is used for the decryption. While in both the keys, they are in relation with each other, they are related with each other through some mathematical function. Now let's move to this called as symmetric encryptions. We are trying to understand what the symmetric encryption is. It's also called as a private key encryption, or people call it is also called as a secret key encryption, because there is only one key and which need to be kept secret. That way also people call it as a secret key encryption. Each party has only one key. Key must be kept secret. And the same key is used for encryption as well as a decryption. And a few examples are DES, AES, and Blowfish or RC4. They are symmetric key encryption example. If you look out for it, where you can see that there is an input message, the plain text, and then there is an encrypt process, and then we got a subsequent output called as a ciphertext. But while doing this, these two things, that's called the algorithms and the key, they are playing very, very vital important role in this. Algorithm should be quite difficult to break in, and the key length should be more so that a better cipher we can generate, and it is difficult to break by the crypto analyst or the attacker. Now, I want to show it to you. There is a conventional cryptography algorithms called as a DES, or we call it as symmetric cryptography algorithms. So I'm I'm explaining DES, one of the algorithms for that category. So DES is the first and the foremost official cryptographic algorithm or a standard came in for use of information security. In fact, it is a modified version of IBM's algorithm called as a Cipher, which was developed in 1960s. And in 1977, NIST has adopted this DES as its first standard algorithm. DES stands for Data Encryption Standard. It is a symmetric algorithm. It has the capacity to take input in terms of block of 64 bits, and it uses as a 56-bit key. This is primarily worked on the two things called as a substitution and permutation. So it is designed using the substitution and permutation on S and P boxes. The same algorithm is used for decryption. Now this conceptually it shows with the visual where we say that there are input from 64-bit plain text. Then there is a algorithm called a DES, which is a block cities. Then we have a 56-bit key, and then we got a cipher of 64-bit output. Then these are the different steps which are available for DES. In the DES, we got the input as 64-bit block of, and then 56-bit key is there. The basic process consists of an initial permutation IP. Then there are 16 rounds of complex key-dependent calculations based on F. A final permutation is generated being called as a inverse IP, and the function F is described based on these two parameters called as Li and Ri minus 1. L and R stands for left and right um, text, plain text, we got it. So we operate on that. On left side or Li is nothing but Ri minus 1. So that is what the text we just assign in, whereas the R is the function which is a little bit complex. We are not explaining it where it has used the P and S boxes, whereas E encrypting is there, and then there's a key generation also there, it is there. So this complex structure we are not explaining, we are not going to explain as it is not much possible in this 30 minutes time. So we are going with the stepwise broad level steps with the DES. We can see in a summarized way. We got the input with a 64-bit plain text. Then we got the initial permutation of IP. Then this IP is converted, or initial text is converted after the initial permutation into LPT, that or RPT, this line left plain text and RPT. We have the 16 rounds which are happening with the function F, and every time we use the key called as a K, and this outcome of this every round is going to be different because of the use of the different keys. Finally, it goes to the final permutation called as FP, and then every block we got the output of 64-bit input and 64-bit output. Output is called as cipher text, whereas input is the plain text. Now DS has various versions. Right now we are not utilizing this simple DS or the basic DS, but this triple DS we use for our certificate generations. Now DS we have different variants for it, for DS with the two different keys, or double DS I'm thinking, double DS with the two different keys, or triple DS with three different keys, or triple DS with the two different keys. This is pictorially shown in the next slide, where we say the DS with the double decryption, encryption, where we got the original plain text. We are encrypted with the K1. Then we got some cipher text. After that, the same cipher text is encrypted once more with the encryption with the K2 QT, K2, the key 2, and then we got the cipher text, which is all. Now the reverse process for that, we got the cipher text, which we are the input to the, and then we apply the key K2 first, get the outcome. Then we once again apply the key K1, and finally we get the plain text original. Triple DS, we are utilizing the three different K. Same analogy has been applied, which was used in the double DS. First encrypt with the K1, second next encrypt with the K2, and next encrypt with the K3. This way we are encrypting this cryptographic algorithm in DS. Now let's move to this another category of the algorithms called the modern cryptography algorithms, or we call them as public key cryptography algorithms. The examples are RSA, ECC or DSA or Engg, etc. In asymmetric key encryption is also called as a public key cryptography. It is based on a mathematical foundation rather than substitution and permutation, whereas in a classical cryptography or conventional cryptography algorithms, they are mostly based on substitution or the permutations. In this case, in asymmetric key cryptography, each party has two keys, the public key and then private key. These keys can be interchangeably used based on applications. Public key is known to everybody, whereas the private key is only kept with the kept secret and to the private to the one. This we can use interchangeably, as I said, the encrypt with the K1 or K2, encrypt in a reverse way. Both the keys K1 and K2 they are in relation, mathematical relation, so they are complement to each other. We can say asymmetric key encryption concept. You can look out for this, where we say that bank has its own public key and every customer has their own private key. So customer A wants to send the information to the bank. So bank's public key will be used by the customer, whereas it is encrypt his own message with his private key. But bank knows the what public key of the customer. So while sending on the channel, public channel or on the internet, the data will be encrypted with the public key of the bank, and as it is encrypted by the customer's own private key, nobody able can open it. Whereas the bank is knowing that who is the legitimate user, what's his, and bank has its own private key. So with that, he can open it, and bank has also the public key of the customer, so that using the combination of this public and private key, they can open. Here I would like to give a sample example of this email and a debit card, where they say that email ID or email ID is nothing but what called is a public key, and whereas email password of your own login, email login, that is we call as a private key. In a debit card case, the debit card number is public one, whereas PIN of a debit card is the private. So in asymmetric cryptography, this is pictorially shown that how does it happens. The only difference is that K1 is used for encryption, whereas K2 is used for the decryption. But there is a important clause for asymmetric cryptography, that it is computationally, as it is based on mathematical foundations, it is computationally infeasible to determine the decryption key, that is D, given only that knowledge of this cryptographic algorithms and encryption key. So one should be not able to deduce the decryption key, even though he got this cryptographic algorithm working and as well as the encryption key. So here is the algorithm called as the RSA. RSA name came from this three contributors who developed this algorithm. It's called as the Ron Rovist, then Adi Shamir and Leigh Edelman during 1997 at MIT University. Now, this is a block cipher using this integers between 0 to n minus 1. As I said, we integrate them, or we code them with the integers, like A is coded with 1, B is coded with the 2, similarly, etc. Now the algorithm is very simple. It encrypts with the CT, called as a cipher text, which is nothing but the plain text. It's going to be power with E, or encrypted with E, that is public key, and it is a mod n. Decryption is a plain text is equal to cipher text s to the power d mod n, where PT plain text and CT is a cipher text. E is an encryption key and D is a decryption key. Both sender and receiver know the n requirements possible to find E and D, such that plain text we can get it using the plain text raised to the power de mod n for all messages. It is easy to conduct encryption and decryption. It is infeasible, but it should be infeasible to complete D given N and E there. Now this slide shows a stepwise RSA algorithm, where in the step 1 we need to choose two prime numbers P and Q. They are large prime numbers. They generally of having the size like 1024 bits, or in decimal digits, if we can say, it is around 300 digits. We need to calculate this N, which is nothing but the P multiplied by Q. Then select the public key E such that it is not a factor of this P minus 1 and then Q minus 1. Select the public key, that is the decryption key D, such that the following equation is true. That is D multiplied by E mod P minus 1 into Q minus 1 equal to 1. And for encryption, calculate the ciphertext CT from the plain text PT as follows. CT equal to plain text raised to the power E mod N. For decryption, calculate the plain text PT from the ciphertext CT as PT equal to CT raised to power D mod N. Now this RSA algorithm is a mathematical based algorithm, so it is difficult to break. It is working on the strategy of called as a multiplicative inverse. So these numbers P and Q, these are the relative prime numbers. They are quite complex numbers, and factorizing the P and Q is going to be very difficult because these numbers are huge and they are in a relation with the relatively prime. So factorization is the major uh, thing which makes the cryptographic algorithm as like RSA as a unbreakable. Now with this slide, I like to just put forth with the differentiation between symmetric and asymmetric encryption. Symmetric key are the faster, whereas problem of the key exchange is there. Every pair needs a key and it is easier to implement, whereas on the asymmetric side, they are slower one. No problem of the key exchange as the public and private key, they are the pair they use it. So only one pair key pair is used per party and they are practically more used across. Whereas with the smaller applications where a faster operations are necessary or a key size is smaller one, symmetric cryptographic algorithms are used. So finally coming with this one last slide where we say that use of cryptographic algorithms. So cryptographic algorithms are used for encryption of the messages, authentication of the messages, and then digital signature generation as well as the public key distribution using the digital certificate. Thank you so much.